Hello everyone. Let's solve the question number 13 for GATE 2025 CS1 paper. Which one of the following techniques used in the compiler code optimization uses live variable analysis? Runtime function call management, register assignment to variables, strength reduction, and constant folding. Let's first understand the prerequisite and try to solve this particular question. So in this particular question, we can see that there are few keywords like compiler, code optimization, and runtime, register, strength reduction, constant folding, and whatever. Let's first understand that. So, what is a compiler? Compiler is a software which translates the source code written in Java, C, or any language into a machine level understanding code. So, what happens is it is turned into a binary machine instruction like MOV, ADD, etc. What are the phases of a compiler? So, first is the lexical analysis. It breaks the particular input code into several tokens like keywords, identifier, symbols. After that, using syntax analysis and grammar rules are checked, and it is also checked whether the structure is correct or not. After that, semantic analysis happens, which ensures that the logic given in the code is valid. Types should match and variable declaration should be correct. After that, an intermediate code has been generated, which basically means the particular piece of code is translated to an intermediate representation. And after that, code optimization happens, which improves the performance of the code. It makes your code run faster and helps in using less memory. Now, the code generation converts the particular intermediate code, particular IR, into a machine level code. The code optimization phase is a phase where like the current question is focused. Okay. So we need to know what is a compiler and the phases of a compiler. In those phases of a compiler, the code optimization is the particular area from which this particular question has been used. So, we actually try to reduce the execution time, also try to reduce the memory usage, and save some cycles of the CPU. It helps making the code faster, smaller, and more efficient. So, suppose, for example, I declare a variable int x is equal to 2 into 4. I can do that by directly writing as 8. So this optimization actually happens at the compile time. We call it constant folding. So 2 into 4 is an expression that will be evaluated. Uh, 2 into 4 is 8. So 8, replacing it with 8 is a bit faster, I would say. So we call it constant folding. And let's understand what is a variable. So variable is just a name of a reference allocated to a particular memory location where the particular data is stored. So int x is equal to 5. X is the name of the variable and it holds a value 5. Live this live variable analysis. So what is this live key? A variable is said to be live at a particular point if its value might be used again. एक पर्टिकुलर वेरिएबल है उसकी वैल्यू अगर दोबारा यूज हो जाती है फ्यूचर में तो उसे लाइव वेरिएबल का नाम दे दिया जाता है if it is not used again then it is considered dead. So if I, let's say, declare int x is equal to 10. Okay, now if I do not reassign any value like x is equal to 20, so so what happens after x is equal to 10? 10 is never used. 10 is ever never used. I reassign the value for x equal to 20, or maybe some another value you can add. Basically, what I'm trying to say, define a variable x to any random value and check whether that random value is reused again. If it is not, so until that point, x is not alive until it is not reused. Until the value is not reused, that particular variable is not considered live. Its value is overwritten without being used. So if I overwrite a particular value, let's say I declare a x as 10 and then I update it with 11. So that particular 10 is not used. So that is what we call a live variable, where when I declare a variable, that variable value should be used in your code. If it is not used and it is overwritten by some another value, without being used, then it is not a live variable. It is considered dead. What is a live variable analysis? It is a part of a data flow analysis done during the code optimization. The objective is to determine for each line of code which variables are still needed and which are not. It actually checks which are the dead variables and which are the live variables. It starts from the end of the program and keeps going backward. So it is not like normally the code goes from top to bottom. No, no, the live variable happens start from the bottom and goes up to the top. It tracks which variables are used in the future lines. So let's say x is equal to 10. It will track, okay, this 10 where all it has been used. If a variable is not used later, as I said, it is considered dead. If it is used later, then it is considered live. It helps the compiler eliminate the dead code. It actually it is kind of an optimization. It helps CPU and it helps in deciding how to reuse the CPU register. So for example, I declare a int a is equal to 5 and then I declare a int b is equal to a plus 2. So observe me carefully. I declare a int a equal to 5. After that, what I did, I declare a variable b, which is equal to a plus 2. So you can see the value of a will be used here. The value of a will be used here. I can write a plus 2. So you can observe that this value 5 will be used here. So 5 plus 2 will be 7. You can declare a C variable. So when you return B, B actually uses the variable 5. So the value of variable A, which is 5. Okay. So that is one thing. Once that is done, once that is done, uh, the live variable analysis here says that A is a live variable because it is used in the second line to calculate the value of B. And C, let's say I declare another variable, A, B, and C. So A was declared equal to 5, for example. After that, let me use a text rather than typing it. It will be easier and it's easy to explain. So let's say int A is equal to 5. After that, I declare B is equal to A plus 2. And I declare int C that is equal to 10, for example. Now, if you observe carefully, let's say the code starts from here. Some function is written, and it ends here. So which is a live variable and which is a dead variable? You can very well observe that int A is a live variable and int C is a dead variable. Why? Because int A is reused again to calculate the value of B, but the value of C is never reused again. So we consider it a dead variable. This helps the particular piece of code understand which one to use and which one to not. Okay. So it actually helps elimination of dead code to the compiler. That is one thing. So compiler can remove the last line C, like the C is equal to 10, because it is a dead variable. It is never used. What are CPU register? I talked about it helps in optimization and usability of CPU register. Let's understand that as well. So CPU registers are basically the very fast memory slots inside the CPU. They are faster than RAM and very few in number. Like I think there are only 16 register in a x86 64. So compiler must choose wisely which variable to register and which variable gets a register and reuse a register when variable is no longer live. So because there are only 16 registers, so the space is very limited. So we have to be very careful. CPU has to be very careful when to allocate a register and when a variable is dead or like no longer live, uh, it should reuse that particular register. Register allocation is a technique during the optimization that assigns variable to CPU register instead of memory for faster access. So it is a technique, optimization technique, which assigns a variable to a CPU register. Uh, it assigns variable instead of the memory. Remember that. It assigns variable to the CPU register instead of the memory for faster access. So because variable holds that value, you can easily access that. So this is register allocation. Remember again, register allocation is not about assigning memory. It is assigning variables to the CPU register for faster access. It uses live variable analysis to know when a variable can be removed from a register. It helps knowing when a register can be reused for another variable. and it also helps understanding of things more easier. It is a simple optimization technique. Now coming to the question. Runtime function call management involves managing the call stack, handling function calls, return local variable, etc. It happens during runtime, not during the compile time optimization. Okay, the question is talking about compile time optimization. Okay, so the option A is not involved because it is runtime function call management. The second option is register assignment to the variables. This is about choosing which variable should be kept in fast CPU register. Knowing when a register is free and it should actually track when a register is free so that it can store some another variable there because there are very limited registers. So if a variable is not live anymore, the register can be reused. This uses live variable analysis heavily because it is every time tracking is the variable live. If it is not live, then that particular register can be reused to assign some another variable. Okay. So this seems like a correct answer. Let's check option C as well. Strength reduction is an optimization where expensive operations like multiplications are replaced by addition or shifts. So for example, uh, x into, if I declare a variable, let's say, let me so if I declare a variable x is equal to x into 3, uh, basically strength reduction, what we will do, multiplication is a costly operation. It will try to replace it with x plus x plus x. So this is a similar operation, similar thing, but at the end, it is a more optimized way. So this is what we call strength reduction. And okay, this is based on the operation cost, not whether the variable is live or not. It does not depends on the live variable or whatever we call it. It only depends whether a particular variable is operation, like what is the operation cost. It does not depends on variable because I think the multiplication is a costly operation, so it is always advised to do strength reduction and replace that multiple multiplication operation with additions. Okay. It does not use live variable analysis at all. Constant folding. So as I mentioned, it evaluate constant expressions during the compilation. Okay. So int x is equal to 3 plus 5. So it will replace it with x is equal to 8 directly. It is a constant operation. You can see there are some constant variable 3 and 5. So let me write that and show you. If x is equal to 3 plus 5, for example, the compiler will replace with x is equal to 8. So this is a constant operation. It is evaluated and replaced. So it is a kind of a optimization technique. So this particular thing, it is about constant. It does not depend on live variable analysis at all. So the correct answer is register assignment to variable, option B, because this is the only technique among all the options that use live variable analysis to decide when a variable is no longer needed so that the register can be reused. So option B is the right answer for this particular question. That's it for this particular video. Till then, take care. Bye bye. See you guys in the next video.